Hello, everyone, and welcome to our webinar, Choosing the Right Database for Your Cloud Application. My name is Larita Baugh. I'm from NuoDB, and I will be the moderator for today's webinar. You'll notice that there is a quick poll that is now on your screen. For those of you that have been on for a few minutes, this is the second question. So you can just take a few minutes to go ahead and answer that while I introduce our speakers for today's webinar. I'm joined by Noel Yuhanna, Principal Analyst at Forrester. Noel, thanks for joining us. And Ariff Kassam, VP of Products at NuoDB. Hi, Ariff. Today, we're talking about how to select the right database for your cloud application. First, we'll turn to Noel, who will give us an industry view of the database landscape, the database requirements cloud applications cloud applications need to consider and recommendations for choosing the right database for your application. From there, Ariff will dive into some of the technical requirements to help narrow your selection, the trade-offs people have had to make with existing systems, and introduce NuoDB's Elastic SQL database. At the end, we'll open it up for some Q&A. But before we begin today's presentation, I'd like to review a few logistics. Our webinar will last just under an hour. The webinar will be recorded and made available for replay, and attendees will be muted during the call. There is a questions panel in the GoToWebinar control panel, so we please encourage you to go ahead and submit your questions there throughout the presentation. We'll address them at the end. And so with that, I'm going to go ahead and close the poll, and we'll go ahead and begin. We're just going to, okay. And Noel, I'm going to go ahead. You need to present, yes. We're going to go ahead, and Noel, if you can, I'll turn it over to you.
All right, thanks a lot. Thanks a lot for having me on this webinar, choosing the best database for your cloud applications. It's a very, very interesting topic, actually. As a Forrester analyst, I get to speak to many customers. These are mid-sized companies, these are large companies from the banks and insurance companies, retailers, healthcare, manufacturing, e-commerce, you name it, across the globe. And, people are building these new generation of applications today that requires a different mindset when it comes to data storage, data processing, even databases, right? And that's what this talk is all about. How do you build a strategy for the next several years so that you can be successful in these new generation of applications you're building? So I'm going to share you some of the things we have learned as a result of these conversations we've been having with customers, and where do you see this trend going, right? I mean, because we have so many different types of databases today, actually, it could be very confusing, right? I mean, I've been doing databases for more than 25 years, and it's interesting how things have evolved over the last few years alone, let alone, right? I mean, we got more choices than ever before today, and we got so many different products, whether it's on-premise, whether it's in the cloud, and what have you, right? Okay, next slide. So what's interesting is from the trend perspective, we definitely see the database market to be about $27 billion, which includes software support and consulting services. And this is growing about 12% annually. Now, what's interesting is cloud databases is already 25% adoption across enterprises, 25%. And this is going to be doubling in the next, it's double in the next 20 years. I mean, 2020 in next 3 years. Now, what's interesting is that there's a huge growth around cloud databases just because it makes it a lot appealing to create these new databases from on the fly. It's got all this good scale, performance, lower cost. So I think, we're going to see, in fact, more than double in the next 3 years. Certainly, there's a lot of potential out there, and I think we get almost a few inquiries on these cloud databases already every week. And as I mentioned, the number of inquiries have been growing as well. Organizations are looking for scalable, high available databases for next generation as we know it. Automation is a big thing, right? I mean, everyone wants automation, There was an interesting conversation I had with this company who's got 65,000 databases. These are not small enterprise, well, access databases, but these are like enterprise class relational databases. And the bigger problem is that how do you manage those 65,000 databases, especially if you want to actually grow by 10,000 in the next 5 years. It's a challenge. And so I think the automation is going to be crucial. You want to minimize tuning. Remember 10 years ago, we spent like 60% of our time tuning our databases, and many people still spend a lot of time tuning, doing upgrades, doing scale requirements, capacity planning. Right? I mean, remember 5-10 years ago, we used to build an application with capacity planning requirements. Okay, this is going to require 16 CPUs or cores and maybe 8 gigabytes memory. Today, you don't have a clue because these applications can scale very well quickly. The application can really explode into millions of users overnight. Right? So you need actually a platform which is more scalable from a high-end perspective. You don't know what the scale requirement would be, actually. That's interesting, Organizations are building a dozen of new applications every month. Now, remember, again, we used to build ERP, CRM applications once a year. Now we're building a dozen of these applications every month. You need actually a platform that is not only scalable, it's agile, but also is highly automated, simplified as well, right? So the time to value becomes very, very critical. So the requirements, I guess, have changed a lot over the last 5 years alone. And I'm sure you're seeing this in your organization as well. Next slide. Now, if you look at the Forrester database market landscape, this obviously includes relational databases, NoSQL environments. You got data warehouses. Now, what's interesting is in the green boxes, you'll see where most of the adoption has been growing more recently. We got in-memory databases have been growing significantly. Definitely, there's more demand from moving into memory because memory is faster, right? It's like 10 times to 1,000 times faster than traditional disk drives. And also, it can scale very well for these larger requirements of applications. You can also run some of these databases completely in memory, which is really good to have. What we believe is going to happen is we're going to be heading into petabytes memory deployments in the coming years. Your iPhone, your Android phone is going to have a terabyte soon. Think about it, right? So we're going to move into petabyte scale in-memory computing in the coming years. So definitely in-memory database is going to be a big thing in the coming years. You should definitely be putting plans together for in-memory databases. Scale-out relational is certainly new area of venture where we are starting to see. Traditionally, we've only had relational databases on a single server, but what could if you run across multiple nodes in a cluster in a scale-out configuration, yet also maintaining ACID compliance, right? Data integrity, performance and scale and availability along with that. So this is an area which we're going to see a lot more growth happening in the coming years. Obviously, NoSQL document database has been a growth over the last few years, where document databases have been generating a lot of adoption, especially in insurance companies and some of the healthcare insurance companies as well. So this is going to be a big thing going forward as well. Cloud and hybrid databases are going to be, again, the future. Well, we are seeing 25% adoption, as I mentioned. Cloud is obviously a big thing, but yet hybrid is also important, right? People are going to be running on-premise and cloud, not just cloud alone, but you got to have a combination of hybrid environments as well. Next slide. So how do you see for operational databases, more specifically? There are three types of operational databases we see today in the industry, right? I mean, we got relational databases, which have been around for doing operational for many years. And we got NoSQL category, which can also do operational requirements. And then we got this whole mix of open source databases, which could also support relational open source and also NoSQL open source platforms. Well, because some of them are commercial, some of them are open source, yet I think they are more open source NoSQL databases versus relational being open source, yet we do see a mix of these, So there are three types of these operational databases, which has got the most adoption right now. Next slide. Now, if you look at it, okay, well, we got a poll. In fact, this is the poll which you guys actually responded to earlier on. And the question came up was, have you deployed a cloud database, right? And if you see the results, 47% said no, but we plan in the next 12 months. Whoa, 47%. Very, very interesting, I guess, And then we got 29% as no, we don't have immediate plans. I'm sure you're going to have that plans change over the course of this year due to competitive pressure. And then they said 18% said yes, we have both managed self-services databases, and I think 6% said yes, databases, we manage them as well. So definitely a combination of results there, but a good thing is that a lot of people are focusing into cloud databases for deployments, which I think should be part of your strategy. Okay, next slide. So what are the pros and cons of the operational databases, which we are talking about, those three things, the relational, NoSQL, and open source databases? Well, if you look at it, relationals have very good, strong asset compliance, transactional capabilities, SQL support. SQL support is still a very strong element for application development and data access, as you can tell. Adoption has been strong with relational. The tooling is very strong with the relational, yet it lacks scale-out architecture, right? I mean, unless you're the new generation of relational databases, traditional databases, relational, don't really have a scale-out architecture. They always contain in a single server. You could always scale up to adding more CPU power, but their CPU power becomes more expensive. Scale-out becomes less expensive in most modern computing era. High-end performance scale is obviously a challenge unless you don't go scale out, which is why NoSQL actually became important for customers to venture out to. Expensive. Most of these relational databases are commercial databases, not really open source. Now, if you look at open source databases, which are a few of those like MySQL, right, which is a common relational databases, they are obviously lower cost. They got an ecosystem around this. We got a community behind that. But again, they have some issues around high-end scale and performance, not cloud enabled. I mean, these are not really built for the cloud, right? I mean, they have the challenge itself. Slow in new features. You don't see them rolling out these new features, advanced features, or driving really the bigger innovation across the board. This is obviously a bigger struggle because, I mean, the timeline is good, the community is great, but guess what? It's a bit slower in adopting these newer generation of things that people need. NoSQL, on the other hand, has got a scalable, sharded kind of model, which can have documents, it can graph. It also have different sharding availability requirements and deliverables. The downside is, not all of these NoSQL databases deliver asset compliance. In fact, they can only, like documents, only deliver asset compliance for a document, not across documents. So they have some issues. It can scale out though, right? But yet it doesn't have a compliance or asset compliance across documents and transactional support. It's got some basic SQL support. Even though they were NoSQL, they have now support for SQL, which I think is good, because SQL definitely is an important element for customers to access information and easy to learn, right, as well. Lacks broader use cases. They have obviously graph databases, you got key value store, and you got document databases. And these address very specific needs, and they are like specialized databases for specific needs, which is good and bad. Good is if you have the requirement for specialized databases, these are good. But then if you don't, then sometimes these databases don't serve the purpose for the other use cases that you're trying to address. Next slide. So what are the new applications demanding, right? I mean, you got these social networking applications like LinkedIn and Facebook's have, right, and Twitter and all these applications, and they have to scale. they have to provide a very good platform to scale, because you may have recommendation engines going on behind the scenes. You may be recommending friends and additional events and other things going on. So definitely you need actually a very connected database, I guess, to which can scale. And you should be able to scale even horizontally even better, right? And not necessarily just a scale-up model. A scale-up model, in fact, may not even work actually, because just adding horsepower alone may not be able to serve that needs. A scale-out architecture actually helps you drive a better strategy. Mobile applications obviously is gaining a lot of ground. We see obviously iOS and Android applications driving many different types of new requirements. As I mentioned, people are building a dozen new applications every month in the enterprise, and that's changing. And because of these mobile devices are quicker to deploy as well. SaaS applications, right? Building from vendors who are rolling out these new types of cloud applications. They want to have a database platform that is more agile, but also highly automated, can deal with unstructured data, can deal with faster real-time access of information as well. Then you got other categories of data of applications, high-performance applications, real-time data mashup, departmental collaborations, and all. So, I mean, you see the new requirements of these applications, and these are changing the way the data is going to be stored and processed all the time. So when we speak to banks, insurance companies who are building these new applications, or retailers, I mean, they're demanding a database that can not only deliver an agile platform, but also scale, ideally scale out horizontally to deliver more value right away. Just keep on adding additional nodes in a cluster, right? That's what they want to do. And these clusters are obviously low-cost cluster servers you're trying to put in the cluster, yet have a lot of value out there as well, right? Can deliver high availability and disaster recovery and all the good stuff. So all of these requirements obviously are new things which companies are looking for. Next slide. Okay, we got another, the second poll which we did earlier on today. Okay, what is your top requirement for a cloud database? So when you do a cloud database, what is your top requirement? 44% said elastic scale out and in. So definitely elastic scale is a very important element, right? I think people want a database that can scale actually without the needed resources from the people, but also on demand based on the applications. It may be able to scale up, scale down, right? Depending on what the requirement would be. There could be an application that needs 1 million users to be supported because it's a holiday shopping season, right? And your application should be able to scale automatically, right? And that's the whole idea behind these cloud databases. Obviously, 31% said highly continuous availability, active. Availability is a very important scenario. The fact that everyone wants a 5.9 environment, right? So definitely is a critical component. We hear that all the time. We can't afford to go down. In fact, based on certain research we have done, a 1 minute downtime could actually cost $10,000 for a company. In fact, in certain large organizations, it could be even 100,000 or more for a minute. Forget about the 5, 10 or hour. So definitely it can cost a lot, and also customer loyalty is also an issue, right? And customer may think, well, if the system goes down all the time, we are probably going to move on to another environment or another company or a vendor. Okay, and then we got 19% hybrid cloud deployments is another one which we see as a requirement, which is, I think, is important. Not just a cloud alone. You want to have a hybrid model, which I think is very important. You want to have the balance of the two. Some people want a hybrid because of security reasons. They don't want to move data all completely in the cloud because they're not really, they feel not really secure, that the data is not going to be as much secure as on-premise. We got all credit card data, we got all this PII, PHI data, which we can't really move. Yet we want to have a hybrid model so that we can use the hybrid resources, the cloud resources on demand to scale these applications as well, right? All right, next slide. So cloud databases are viable as we know it, right? I mean, for different types of things going on, whether there's elastic scale. As we know, elastic scale actually is a big one, I guess, based on the poll, which is why people actually use cloud databases. Definitely the need for scale up, scale down, as much as automatically being done, being able to provision, lower cost, better availability, backup recovery. Even security could be good. Maybe obviously you got to be cautious about it. I mean, you don't have to just dump data into the cloud and be happy with it. No, you want to obviously protect the data. You want to make sure you got encryption enabled on the network. You got encryption at the destination at rest as well. So you want to make sure that if you're going to put data in the cloud, make sure you got security, encryption, auditing, monitoring available as well. And you get updates right away. In fact, all of these database vendors are trying to move towards the cloud-first model. Now, by the way, cloud databases are not exactly the same as database as a service environments, right? Cloud databases are different in the sense that it may be optimized for the cloud environments, right? It could be certainly managed cloud. You can have self-managed or even private clouds, public cloud environments. But database service is more like multi-tenancy, where you want to slice a database and give it to an application to a user or consumer as well, right? So that's how you look at it from a cloud adoption. But the good thing is that all of the new features of the databases can get deployed very, very quickly. You don't have to have a CD being burnt every 6 months or a year coming down your doorstep trying to install it. Well, the cloud is already enabled right there, which gives you an update of these features in minutes, right? I mean, and they're rolling out every month new features, which is really cool to have, I guess, as well. Okay, next slide. So cloud offers many use cases. So based on customers, what do we see out there? Well, they're having mobile applications. I mentioned e-commerce applications, which are completely in the public cloud, cloud using cloud databases, analytics and predictive analytics in the cloud, social media, data services, departmental line of businesses. I mean, it's got a lot of variation of different types of applications you can build and use cases. Customer churn, customer 360-degree view of the customer are critical components of these offering as well. You can build these new types of applications right away. Certainly, definitely a lot of potential out there from a deployment perspective, but we definitely see all kinds of applications being moved. You can also move existing applications to the cloud because some of these cloud databases are SQL enabled, which is a very critical component of movement, because you can actually help you migrate these databases onto an elastic platform in a very effective sense. You don't have to re-engineer your database or the application from scratch. Yet you can help them do the migration a lot simpler. So definitely the cloud databases offer many choices. And I think the good thing is the potential is huge, right? I mean, especially when you have these tier one applications that demands a lot of horsepower and storage requirements. Imagine you're building those 50, 100 terabyte transactional operational systems. You need those not only storage for backup and recovery and disaster recovery and test and dev environments, but yet you also want to make it more scalable, which is why cloud offers you a lot of these potential as well. Next slide. So what to look for in the cloud? If you are, and we saw that almost like 30 to 40% people are looking at the cloud in the next 12 months. So what are you going to be looking for in a cloud database, right? Well, you need to have a scalable and a distributed platform in the cloud. What it means, it should be not just cloud that, hey, I got cloud databases, I'm going to go with that. And you got to look at how scalable are these databases in the cloud, right? Are they scale up, scale out? How quickly can they scale out as well, right? Because you may be scaling from 10 terabytes to 1,000 terabytes, or what you call petabytes. And you may have 10 users to 1 million users as well coming based on these applications. How quickly can they scale to deliver more value? What about asset compliance and data consistency as well, right? some of these databases may not have asset compliance, which is an important element, especially like in these critical applications, like in banks, insurance companies, retailers. In fact, it may apply to every industry where you want consistent data. You want not only trusted data, consistent data, but also data that actually can be able to meet all of these new use cases you're delivering, whether it's a customer churn, customer 360, fraud detection applications, and all the good stuff. Support operational transactional requirements together. I mean, we are seeing a big trend where the separation of these two, which have been there for decades, isn't being there in the future, because they're going to be converging the operational and transactional requirements, because applications should be able to support both technically, right? Highly automated with minimal zero time, full access to SQL, comprehensive security built-in, subscription model, geo-distributed backup and discovery, and disaster recovery scenarios. So, I mean, all of these requirements are very, very critical. So I definitely encourage you guys to look into those things as you start to build a cloud database requirements, Okay, next slide. So one of the recommendations, I guess, we have is to look beyond traditional databases for cloud. You could use traditional databases for the cloud, but the problem I think would be is that would they be able to scale, right, to your demands? If you have a very small applications, well, it may work fine. But if you have a very complex, large environments, which needs to be more on demand, right? Because you don't know the requirements. Definitely look for databases that can do high-end scale and definitely deliver more value right away. Consistency, integrity is also important for supporting trusted data, right? I mean, you want to be able to have trusted data. Some other scale-out architectures may not deliver what you call eventually consistent model, may not have trusted data, because if your query goes to one node and another query goes to another node, guess what? The data may not be consistent across these nodes, right? So depending on the applications, it may be fine, right? But obviously the modern applications demand differently. they want trusted data, right? So look at those things for your applications when you're making a decision. Look for databases that are highly automated. I think this is very important. From tuning, optimization, backup and recovery, all of these should be automated as much as possible. You want to minimize your DBA effort into these environments as much as possible, right? Ensure that sensitive data is well protected, right? Encryption, auditing is enabled, especially when you're moving into the cloud. You want to make sure this is done because all databases don't really have complete control of these data sets you're driving. You want to make sure that the data is protected. Ensure solutions can scale, deliver performance, as I mentioned earlier on, and look for solutions that are lower cost as well, because sometimes they are hidden cost as well. In the cloud databases, you've seen that. So you want to make sure that they are lower cost, and you're able to save money when you go to the cloud as well, like public cloud, right? Ideally, you should be able to save 20% or more for moving from on-premise to the cloud. And I think a good thing is that you have a lot of flexibility with these cloud databases, which I think is really phenomenal. Next slide. And with that, I would like to thank you and hand it over to Ariff.
Thank you, Noel. That was very insightful. So the next section of this webinar, I'm going to go talk through some of the ways to think about narrowing the landscape of your choices. Noel did a great job outlining a lot of things that you should be looking for as part of your cloud databases. We'll touch on some of those again in a little more detail and talk through sort of your choices that you have out there when you're thinking about cloud databases. So obviously this is a very obvious slide. The biggest thing you need to do is understand your requirements. And they can be broadly divided into sort of business requirements and technical requirements. We're not going to go through the business requirements, but you're going to have to take a look at the total cost of ownership, as well as your growth projections, how fast you want to do releases, all that you need from a business perspective. We're going to focus on the technical areas and understanding your requirements from a technical perspective. And broadly, they can be thought of from in 4 different areas: the workload type, your sort of architectural requirements, your transactional requirements, and whether or not this is an existing app that requires SQL support, or whether you want to build something that has SQL support, or you're willing to change your access models to an API or NoSQL model. So the first consideration is what is your application trying to do? And Noel, again, touched on this earlier in his talk. You have analytical databases out there that are looking at data, trying to predict trends, trying to understand how to optimize businesses, how to run businesses. You also have your traditional general purpose OLTP relational databases that really perform operational or transactional workloads. Noel also alluded to a newer type of databases that are currently being seen out there that can support both analytical and operational or transactional workloads. In this case, the analytical workloads aren't your complex data warehousing queries that range across terabytes of data. They're more operational analytical in nature, where they're real-time queries that could potentially change the scope of a transaction. Fraud detection is a classic example in these use cases, where you need to make a decision based on the behavior of the transaction, whether or not to allow that transaction to complete or not. And then you've also got specialized requirements. These could be time series database from sort of an IoT perspective, or even graph databases for different modeling. Stream processing, again, another IoT use case for being able to stream data to a platform, potentially do some analytics on that data as well. And then you've got very specialized scientific platforms that exist out there. So a lot of your choice in your database landscape is going to be driven primarily by the type of workload you believe your application is going to be performing. The next critical piece is sort of the architectural requirements, and we've sort of highlighted 3 major pieces. What is your availability requirements and disaster recovery requirements? That will dictate your strategies on the type of databases that you'll deploy within a cloud environment, across cloud environments, or across multiple cloud providers, either public or private, and whether they're different cloud providers. Again, I'm sure everybody's aware of outages that have been seen by some of the cloud providers. If all your services are locked into one cloud provider, that outage will affect you significantly, and you may want to consider spreading your services across multiple cloud providers to prevent issues within a specific environment. Also touched on by Noel was this idea of hybrid. Is this a new application that you're deploying? And if it's a new application, do you have any restrictions on whether or not the application can be fully cloud-based or has to span an on-premises and cloud environment? If it's an existing application that you're migrating to the cloud, there may be a transition period where you need to have a hybrid model where you've got data and applications on-premises, as well as some database and data capabilities in a cloud. And so we typically see customers doing sort of an on-ramp, cloud on-ramp kind of strategy, where they're migrating an existing application from an on-premises to a cloud environment, and build out this hybrid model where they deploy a few nodes in the cloud and migrate over time as they get more comfortable and they build out capabilities in their application to support that model, and then fully move to a cloud, or maybe maintain a hybrid strategy depending on the use case. And then finally, another big component in the architectural requirements is this idea of scale out and scaling requirements. Again, if this is an existing application, you may have a very good idea as to what your workload and your scale requirements are. You've been running this application for a year or two and have a very good idea what either the nature of the workload, the number of users that you may have. If this is a new application or a new service that you're providing in the cloud, it's very hard to predict. It may be very hard to predict what that workload and scale is going to look like. As Noel again mentioned earlier, 5-10 years ago, everybody had to go through the exercise of sizing the database based on projections of how, the load that they believe the workload is going to do. And 99% of the time, everybody was wrong. Whether that was sized it too small and you need to upgrade immediately after production, or you wait 3 years to get to the scale that you think you were going to get day one, at which point in time you've over-provisioned your environment and are underutilizing your systems. So the question to you is, when you start thinking about your database requirements, is do you have an understanding of what the workload is going to look like, the type of scale requirements you're going to have, and what time frame you're going to do? Obviously, to reduce costs, you'd love to be able to scale out on demand and scale in on demand so that you're utilizing the systems as highly as possible, rather than sort of being over provisioned and waiting for the point in time where you've got the right load on your systems. Traditionally, if you've deployed databases and you look to do some sort of scale out capability, traditionally there's basically two models of scale out. One is a clustered shared disk architecture. This could be simple as MySQL clusters, where it's more an availability story, not a scale out story. But if you've got something like Oracle RAC or IBM Pure Scale, where they've got shared memory clustering as well as shared disk clustering, then you can get some scale out in those models. The more traditional method of scale out is a sharded approach or shared nothing approach. Obviously, this is the basis on which a lot of NoSQL databases achieve their scale out by partitioning across multiple nodes. But you can also do this with a traditional database. You can shard your traditional database and do scale out in that manner. The disadvantages of these types of traditional scale out architectures is that they're very complex. Oracle RAC and IBM Pure Scale are very complicated systems. They require significant investment in sort of SAN technologies for the disk. Partitioning and sharding is also very complex. It requires a lot of knowledge up front on your application workload on how to best partition and shard your application across databases such that you don't have any hotspots. And if you do have hotspots, then you have to figure out how to repartition and reshard the database to alleviate those hotspots. It's difficult to manage. These could be, again, in a sharded environment, you're dealing with hundreds of partitions probably, or shards. And basically each instance is its own database that needs to be managed independently. And again, sometimes may require changes to the application to support a scale out architecture. The next sort of architectural and technical requirement is transactional guarantees. Again, depending on your application requirements, if this is an existing application, it may already be built on specific transactional semantics and may require ACID or partly ACID guarantees if it's doing business critical data application management or financial transactions or any sort of database of record system. Some of the newer web applications don't need ACID or transactional guarantees. Some of the social applications or social mobile apps also don't need transactional ACID guarantees. Those are obviously very well suited, and a lot of the internet companies out there, like Facebook and et cetera, have built large data management solutions based on these eventual consistent NoSQL partitioned scale out, highly scaled out systems. Right? And again, it depends on the application, and it also depends on the amount of complexity you want to build into the application to be able to manage the database semantics and how data is represented and replicated and made consistent across the nodes. So a lot of the times the NoSQL applications have to take into account that there could be different views of the data, and there could be inconsistent views of the data. and the application just needs to build that into its knowledge. It's not easy, but it is a way to handle scale out depending on your needs. And then finally, the last piece that we sort of talked through is your SQL support. Again, is this an existing application that or has already built a lot of tooling around the availability of SQL? Does the cloud database, if you're migrating an existing database that's based on SQL, migrating to a cloud, obviously you start with a cloud database that supports SQL semantics. SQL, as Noel pointed out, has a large ecosystem and tool set out there that a lot of people are comfortable with and have built a lot of operational procedures around. And SQL databases, again, abstract the knowledge of how data is managed from the application. So a lot of the data management tasks are pushed down to the SQL database versus moved into the application. Again, there's no right answer here. It depends on your application and the complexity of your application. If you can handle and want to handle data management tasks and maintaining versions or schemas or access patterns and optimizing access patterns within the application, then SQL support may be something that you don't really need. If, on the other hand, if you've got an application or building an application and you want to simplify the application code in terms of optimizations, performance, schema management, those are traditionally what a SQL relational database or SQL databases have done in the past. And so you may need those things in your cloud database as you sort of look for the next solution. So as a SQL database, the customers that we've been talking to, the customers that we've been engaged with, traditionally come to us because they are looking for a SQL database that elastically scales out, specifically in cloud or across hybrid environments. So customers are saying, we want elasticity. We want the benefits of a NoSQL database that provides scale out, scale in, availability, the ability to deploy on virtual systems, cloud systems, on premises. But I also want to keep my SQL capabilities, and SQL being transactional ACID semantics, the SQL language abstraction and management capabilities that I traditionally have with my existing SQL database, right? And so we've defined this idea of an elastic SQL database that combines the scale-out simplicity, elasticity, and continuous availability that cloud applications require without losing the transactional consistency and durability that applications require from a database of record. So briefly, what is NuoDB and how does it achieve this elastic SQL capabilities? So NuoDB is a modern database architecture that has effectively taken your traditional legacy relational SQL database that is a monolithic process that controls both transaction management, transaction processing, and storage management into a multi-process distributed system, right? We have fundamentally split the traditional database into two different types of services. One is a transaction processing service, and one is a storage service. The transaction processing service, represented by the dark green circles at top, are in-memory processing, fully in-memory, only in-memory processing engines that parse SQL and execute the SQL against in-memory data that is available in that network. We also have a durable storage layer. So for databases of record that have to have durability, we maintain multiple processes to store and make multiple copies of the data available. It's fully anti-SQL compliant, and we can deploy within a data center, across data centers, in different clouds, in containers. So we've got the flexibility, the architecture has the flexibility to have a lot of different deployment models. This is a bit of an eye chart, and maybe a little bit hard to read on your screen, but the top 3 diagrams represent how you can sort of scale out the NuoDB environment. And then the bottom 3 diagrams show how NuoDB provides continuous availability across the application. So in the top diagram, it shows 2 TEs. These are the transaction engines that are fully in memory, and 2 storage managers that are the durable points for our database. Right? And the applications are connected up to the transaction engines and working, executing their workload across 2 different processes that are fully active and fully available, processing the requests from the applications. You can easily, in the second picture, you see the application scaling out by adding either a load balancer, adding another node, another web server, however the application is scaled out. And then on the third image, we can simply add a transaction engine on the fly without any outages, without any downtime, dynamically add a new transaction engine that could start serving that application that was just recently added to provide that scale out capability. And then the bottom 3 talk about availability. So in this case, that one new transaction engine that we just added fails for whatever reason. The server went away or whatever happened to that server in the cloud. The application will see that failure, we'll get a reconnect. You'll do a standard connection pool that will then go to the next available transaction engine. So the application can connect up to any of the transaction engines and continue its work. So from the application's point of view, it's just a reconnect. There's no loss of data, there's no loss of availability to the application. So I wanted to talk through a customer use case. So Alpha Systems is a UK-based software provider that provides software for managing assets, financial assets to companies. For example, a lot of the car manufacturers use Alpha Systems software to manage leases. So customers lease their cars, and the Alpha Systems software is used to manage those leases. Alpha Systems just a couple weeks ago issued an IPO on the London Stock Exchange, and it was the largest IPO, UK IPO, since 2015. The challenge that Alpha Systems had is that they've had an on-premises solution, and they were losing business or were not growing as fast as they wanted to without a cloud or SaaS offering. And so they needed to migrate their application to provide a SaaS solution in the cloud. They tried MySQL in their cloud environment, but they're having problems with MySQL, scaling MySQL, and the Oracle licensing in AWS was too expensive for them. So they chose NuoDB because of our elastic scale-out capabilities, as well as our continuous availability and providing active-active across multiple cloud environments, while maintaining transactional SQL consistency. The benefits that Alpha found is obviously a huge ROI for Alpha and their clients. We were able to reduce their costs by 90% over their Oracle costs, and we've increased their performance as well as availability and response time capabilities. Just a brief slide on NuoDB. Who are we? We were founded in 2010. We are a management team made up of database pioneers. You can see some of our logos, customer logos onto the right. We have patented this elastic SQL database for the last several years. It's been built from the ground up for cloud technologies. It's not your traditional legacy SQL database.
Great, thanks, Ariff. So I'd like to take this time to remind people that you can go ahead and ask questions in the GoToWebinar control panel. We're going to take a couple that have come in through throughout the time here. The first, I think, is directed to Noel. Noel, could you give us an idea of which use cases and what kind of workloads and applications are moving to the cloud sooner than others?
I guess, it's all kind of use cases. I guess I'm moving to the cloud, as I mentioned, especially the ones which need scale, right? I mean, if you look at it, the way we build applications, I mean, we obviously start with a smaller build of the application and grow, and that's the traditional approach of building an application, right? I mean, you start small and grow, and you actually fix the application down the way. But today with the competitive pressure, today with the digital business initiatives going on, you don't really have time to actually build an application with a building block kind of model that, hey, we're gonna start with a 1,000 user, then we're gonna start with a 10,000 user next month, and we're gonna start to grow this. Because obviously the application has to scale linearly, but also budget is an issue. People don't have ample money and resources available for these applications. So you got a cost equation on one side, and the second side, obviously, you got the scale and the availability of these applications that demands it more differently than what you've done in the past. Which is driving the need for this, for this cloud. Now, obviously, as I mentioned, what are the best use cases? Whether you're building social applications, mobile, SaaS applications, real-time applications, fraud detection, customer churn, customer intelligence applications. All of these are very, very suitable for the cloud, I guess. And that's what we're seeing. Whether you're a bank, insurance companies, retailers, healthcare, oil and gas. I mean, all these companies do need these agile, so to speak, platform which can deliver scale, performance at a lower cost. Which is why cloud is obviously gaining a lot of ground.
Great, thanks. And you made a comment during your presentation about eventual consistency and paying attention to kind of importance of transactions. Are there use cases that you would recommend more for sort of that eventual consistency or NoSQL model versus the ones that are better suited for relational databases?
Yeah, I mean, I think every application is different, right? I mean, the fact that if you look at it, you may be eventually consistent model, like some of the travel sites, when you go to a travel site and you're booking a travel, they want to actually have a platform that can scale very, very quickly, right? Yet the data may not be consistent in that kind of scenario, right? You're booking a travel and all of a sudden it says, by the way, the prices have increased actually all of a sudden. Why? Because the data wasn't consistent, I guess, right? So, I mean, it depends on the use cases we have seen. Typically for documents, like if you're doing, say, social networking, eventually consistent may be fine, right? I mean, if someone posted something and you don't get in for like 3 seconds, does it really matter? No, not really, right? I mean, you're not doing a banking application, right? You're not doing a transactional application, right? So I guess, eventually consistent kind of models are very good for those kind of social media, social networking applications, or when you're dealing with maybe in IoT data, I guess, which may not be needing consistency data as well as much. So there are certain demands for certain things, but I think, if you look for traditional applications like enterprises are building, those customer-facing applications, you want to have a consistent model for that. Consistency is very critical. Asset compliance is very critical because you want to get a single version of the truth for the customer and in real time. Like if a customer calls in complaining about something, you should know about this customer in and out until that second. Now, it doesn't matter how you get to the data, right? But that's an important model altogether in having versus being inconsistent, I guess, for that reason, right? So I guess all applications vary, so yeah.
Great, thank you. Ariff, I think the next question is for you. Is it possible to write the same data from multiple nodes in NuoDB?
So all our processes are fully active. So you can have the application connected up to all the nodes in the database. So you can be able to do full reads and writes across the entire database. And that is both within a single environment and across multiple environments. So again, if you've got a hybrid model, you can have an application processes doing both reads and writes to the database that spans on-premise as well as in a cloud environment.
Great. And then the next question is, with respect to continuous availability, you mentioned the loss of an existing TE or transaction engine. that it will auto redirect requests to another TE. This person's curious about what the transaction engine stores locally, and whether the storage manager is where the data physically resides, and whether one can scale out the storage manager.
Yeah, so those are all good questions. The transaction engines are in-memory systems that cache data based on application workload that is directed to that transaction engine. So in the case of that failure scenario where the application was doing a workload against transaction engine 3, for example, and transaction engine 3 went away, when the application connects up to transaction engine 2 and reconnects, so let's assume the transaction was rolled back because of the connection failure, and reconnects and tries to replay that transaction, it will make the same requests, and if the data does not exist on transaction engine 2 at that point in time, it requests it from the storage manager, which can have the full copy of the database. The transaction engine 2 may already have the data already in its memory. If it does, then it doesn't need to go back to the transaction engine to get that data. The second part of the question was whether or not the storage engines can be scaled out. So there's two modes for the storage managers. They can either have the full copy of the data. So if you've got 2 storage managers running, then you've got 2 copies of the data. If you want sort of a K factor of 3, then you can have 3 storage managers running for redundancy. We also support the idea of partitioning the data across storage managers. This is a concept called storage groups within NuoDB. And in that case, you could have a third of the data across 3 different storage managers, at which you can then scale out that data across multiple servers.
Great, thank you. Noel, I think the next question is a follow-on to the previous answer. Do scale-out relational databases sacrifice transactional consistency for the ability to scale out?
You know, I mean, there are new generation of applications which are new types of databases that are doing consistency, I guess, with the relational NoSQL architecture, right? But traditionally they haven't been doing that, I guess, right? So that's a big challenge. But if you do consistent model with the relational scalar architecture, it can be very, very complex to do that, I guess, yeah. But yeah, I mean, it's totally a different requirement altogether. Yeah.
Ariff, does NuoDB sacrifice transactional consistency for the ability to scale out?
No. So we are a full ACID, fully transactional consistent database. We have standard isolation levels for accessing data within a transaction. We are also an MVCC database, multi-version concurrency control, which also allows us to scale reads and writes without locking.
And then a follow-on to the continuous availability question we had earlier, would you still be able to maintain the request level SLAs when transitioning a request from the failed TE to the active TEs?
So again, it really depends on it depends on the SLA. Obviously, there is a little bit of a hiccup when we're moving from a failed TE to an active TE because of that reconnect to the second active TE. Again, depending on your SLA, if you're right up against your SLAs, then maybe not. But generally, your SLAs are sufficiently have enough room that particular network reconnect is minimal and doesn't affect your SLA.
Great. And we're unfortunately at the end of our time here. So if you'd asked a question and we didn't have a chance to get to it, we'll follow up with you at the end of this webinar. We have recorded the webinar and we'll send it out to anybody for your future review. And in the meantime, I want to extend a special thanks to Noel and Ariff for leading our discussion on selecting a database for your cloud application. And thank you to our audience for joining us today. Hopefully you found the session today interesting and informative. And we'll see you the next time. Thanks so much. Bye-bye.